Okay, so we're on to the last mini lecture for chapter 12, and this is the idea that predator-prey interactions, so far been talking about them in terms of pairwise interactions, right? Been talking about one predator interacting with one prey species, one to one. And in this case, the predator benefits from the interaction, the prey has a negative, right? But it turns out, and hopefully you learned this in the first couple lectures of the semester, that ecology doesn't happen in a vacuum. That ecology is characterized by high interconnectedness, and that interactions in one part of this interconnected web can cascade out to have larger effects, right? This is the Ribia snails and birds and runoff story, right? And so here we're going to talk about a couple specific ways where predator-prey interactions, can cascade up to shape communities. Right? Predation can cascade up to shape communities. The simplest form of this is just an indirect interaction in a three-species system. So let's imagine a three-species system now, where we have our animals eating animals, and then this same animal eats a plant, right? We have little Pac-Man. So we have a predator, let's call this pred. We'll have this prey, and we'll have this plant, right? And the interaction between the prey and the plant is also a consumptive interaction, right? Also a consumptive interaction. So here we have a predator that eats a prey that eats a plant. In this simple system, then we have two kinds of effects, right? We have the direct effect on the survival of the prey as driven by the predator. That's this plus minus. Oops. That's this plus minus, right? Geez, what's going on? Let's fix my... You don't need an eraser right now. We need a pen. This interaction right here, right? That's a direct effect. Predator directly eats prey. But you can see this is a very clear cascade that if the effect of the predator on the prey is negative, then the effect of the prey on the plant should be positive, right? A positive times a negative times a negative is a positive, right? So we have predators decreasing the population of the prey then are fewer in abundance and eat less plants. That is called an indirect effect. So we have direct effects and indirect effects, right? But this is a really simple system, right? This is a really simple system. More predators, fewer grazers, more plants, right? And that maybe isn't intuitive. Hopefully it is after you watch the first couple lectures of the semester. But some important community implications of this are that, top-down pressures, we call these top-down pressures, predators eating prey, so there are less prey to eat plants, can actually maintain diversity, right? So one of the coolest things that happens in natural systems, one of the coolest stories of restoration ecology in natural systems is the reintroduction of wolves into Yellowstone, right? These were keystone predators, central predators in this ecosystem that were removed by humans. And in the absence of these predators, prey populations boom, right? When you reintroduce these predators, now prey populations are severely depleted from, predator-free baselines, and we can have plant communities recovering diversity, right? So in this case, predators can actually maintain diversity at lower trophic levels like plants, right? What's really cool is that these effects don't have to be consumptive. And this is one of the neatest outcomes of this restoration story in Yellowstone, is this idea that it's not just that the wolves are eating the herbivores, but in fact that they're having non-consumptive behavioral effects on the herbivores, right? So as an herbivore, being afraid that you're going to get eaten makes you act differently. You forage in different places, you take less risky behaviors, you spend less time eating, more time being vigilant, all of these things we learned in the behavioral ecology chapter, right? And so you can actually have this sort of like mind-blowing situation where just the presence of a predator, even in the absence of a predation event, can increase diversity at lower trophic levels, right? So this is the kind of complexity that ecologists really get excited on, right? Really get excited on. And this is a very simple system. In your book, it goes into these much more complex systems where you could have series of cascading effects. So we could imagine a situation, right, where we have a predator, our little wolf buddy. Here's his ears and his whatever, right? Tail. And he eats a couple of different kinds of herbivores, right? We have big ungulates with antlers. We have, why do they all only have 2 legs? We have small badger-like things, right, with also 4 legs. We have little squirrels, right, that have bushy tails. And then each of these has their own unique set of herbivores, some of the plants that they eat. And some of them are specialists, and some of them are generalists, and some of them are shared, right? So there's some plants here, plant species 1, and plant species 2, and plant species 3, and plant species 4, and plant species 5, right? And in this system, each of these consumptive interactions, each of these, this is plus minus, this is plus minus, this is plus minus, right? Let alone, we haven't even talked about the minus-minus interactions between plants that are competing for each other, or the minus-minus interactions between this ungulate and this little badger that both eat the same plant, right? You can imagine then how complex this system is and how difficult it could be to predict. What is one of the coolest things in modern food web ecology, modern predator-prey ecology, is that we are building towards a predictive framework for this kind of system, right? This is a thing that we're not far from understanding in at least the simplest cases. And I really hope that we've made the case so far that that's a cool thing, right? I think it's a cool thing. So, okay, that's the last thing in chapter 12. I'm going to give you a couple mini lectures about chapter 13. And hey, it worked. Tech stuff fixed. Thank you all for bearing with me.